iNaturalist is another organization which focuses on biodiversity conservation. So they have this nice app where they let people take pictures and upload their own pictures of insects, animals, whatever you find around, plants and so on. And they want to promote conversations around biodiversity. There are people, experts who help you identify what is that species, and they have a conversation in terms of where is it available and so on. So they want to promote that. And they have very rich data. We have people uploading high resolution, high fidelity snapshots of different kind of species from around the world. So this is all available in their database. They wanted to automate the process of identification of the species. And here the challenge is that there are over 5,000 odd species which they had in one data set. Eventually this was a Kaggle contest also. It's called iNaturalist Kaggle contest. And about 5,000 plus species. And all of these rolls up into 13 super categories of types of species. So all these species had to be identified. You can imagine that the earlier we talked about 12 salmon species, whereas here we're talking about 5,000. And the label and images was not a problem. All of it was neatly curated and labeled. The challenge was that we had skewing of the data. Some species had several thousands of pictures, whereas some had just under 100. So there's a heavy skew in terms of certain types of species that are mostly available. So if we have to accurately identify all 5,000, we need to do something about it. So that was one major challenge. And second, the data was really huge. We had about 180 GB of data and running into almost, I think, about 600,000 or so. So the first step we did was to solve the skewing problem. We duplicated. There's a standard procedure followed in machine learning where you duplicate and then you create multiple images for the one which is not enough to start with. So that we had done, and then eventually the number of images with all of this pre-processing grew to 2.5 million. So we had to process all of that and build models for it. So we went through that, and we tried a lot of these the CNN-based slightly simpler architectures. It didn't give us great results. So the accuracy was around 50% or so. Eventually we moved to more complex architecture. There's Inception V4 and Ensemble DenseNet, which is a fairly comprehensive, complicated architecture. That started giving us very good results. So eventually we settled on that. That also had a problem of one single epoch took a few days to run. So we scaled it to 80 GPUs, and we set this up on Batch AI for Microsoft. Batch AI, which has they have the cloud offer. So it was pretty efficient, and it was able to run much faster. So that way we cut it down to 25 minutes for one epoch, from about 16 hours to about 25 minutes. And the accuracy shot up to 78% for top 1 and close to 90% for top 5, which is pretty good. And this was comparable with the Kaggle leaderboard. So this was a little different from the early one. We had a hierarchical model, much more complex one, and scaled to a lot more GPUs. And that way this problem was solved. And this also has been packaged into an API so that this can be taken up by any other NGO